Bamboo is a common term used to refer to the Bambusidae subfamily within grasses, or Poaceae. Consisting of 1,482 species across 119 genera, bamboos are the only major lineage within Poaceae to have adapted to and diversified within forest habitats. Most bamboos grow much faster than the average lawn grass and even rice, wheat, or corn, and are much taller and broader. Bamboo plays an integral cultural and ecological role in the tropical and subtropical regions of Asia, Africa, and South America, and has over 1,000 documented uses with a rich history of traditional applications. It is the fastest growing and most versatile plant on earth, with an average growth rate annually of 5 to 12 tons per hectare of air-dried biomass. While Brazil has the highest land area covered by bamboo, China is the world's largest producer and exporter of bamboo products. The sustainable production and use of bamboo may be correlated with multiple UN Sustainable Development Goals, as seen here. The advantages of bamboo as a biomass crop are its fast growth rate and biomass accumulation rate, its very low fertilizer or pesticide requirement, the ability to grow on diverse soil types and marginal land, its regenerative nature and erosion protection via underground rhizome systems, its low capital investment needed for production, the favorable chemical composition for biorefinery. The commercial applications of bamboo are traditionally in the utilization of bamboo biomass in its original form as scaffolding, furniture, building materials, consumer goods, electronics, and even wind turbines, or in the extraction of fibers to produce textiles, paper, or bamboo timber, or as food, feed, and traditional herbal medicines, either in its raw or processed form. Valorization of bamboo biomass at the molecular level is gaining popularity, especially in production of biofuels and various functional chemicals. These may be represented as such on a biomass value pyramid. Despite such a wide range of applications, it is interesting to note that bamboo is not very popular in the realm of bio-based and circular economy applications. This may well be due to the fact that bamboo is not a notable biomass resource in Europe or North America, where most of the research and development in this regard has been taking place. However, in recent years, bamboo has been gaining popularity as a biomass resource in Asia, especially China, which was responsible for 67% of bamboo-related exports in 2019, and to a lesser extent in South American and African countries. The global bamboo market was valued at $53.28 billion in 2020 and is expected to expand, reaching $83 billion in 2028. Timber, plastic, steel, gasoline. Can bamboo be an alternative to all of them? Theoretically, yes. Bamboo has a tensile strength comparable to that of mild steel or fiberglass. Giant bamboo has a tensile strength of 397 newtons per square millimeter, while steel lies between 250 to 450 depending on the grade. Across the world, bamboo has been traditionally used to build houses and furniture, being replaced during and after the Industrial Revolution by various man-made materials. In China, there is a growing popularity of green buildings where bamboo is the primary material. Bamboo scrimber, a type of composite material derived from bamboo waste and crushed bamboo fibers, is also gaining popularity for interior and exterior applications in construction, with substantial investment into research and product development. This diagram denotes two pathways for bamboo scrimber production. A vast range of consumer goods, especially at lower price points, are derived from fossil origin plastics. The plastics market size was valued at $579.7 billion globally in 2020 and is expected to reach over $750 billion in 2028, fueled by increasing plastic consumption in construction, automotive, electrical, and electronics industries. However, for most products derived from plastics, there are bamboo origin alternatives. However, in most instances, these bamboo products are not very price competitive or widely available. From a biological and functional point of view, bamboo is a good timber substitute. While woody bamboo species such as goadoa and dolu have similar properties to wood, bamboo being a grass species, its rapid growth sets it apart from timber-producing trees. Its annual harvesting system, with a quick return on investment, reduces the need for deforestation or clear felling of bamboo and can protect stressed forest resources. However, bamboo is often included in legislation aimed at timber trade regulations such as the Lacey Act in the US and FLEGT Action Plan in the EU, which hinders its consumption as a timber alternative. Moso International, a company based in the Netherlands and China, is one of the world's largest bamboo-based companies. They have a wide catalog of bamboo-based exterior and interior materials, along with various architectural and interior design projects based on bamboo. Founded in 1997, their products are carbon neutral or better and carry 30-year warranties. They are also working on a 100% cradle-to-cradle compliance. Other notable companies working in bamboo are mentioned here. Another common application of bamboo is in the production of biofuels. In India, the state-owned Numaligarh Refinery Limited has set up a joint venture with Kinopolis, a Finland-based biorefinery company, and Fortum, a clean energy company, to set up a bioethanol factory with an annual capacity of 60 million liters of ethanol, along with 30,000 tons of acetic acid and furfural. This joint venture is set up in Assam in northwest India, where 66% of India's bamboo production may be found. The Indian government aims for 20% biofuel in gasoline by 2030, meaning an approximate 3,500 million liters of bioethanol demand per annum. This move is meant to promote an organized bamboo sector in rural areas of India through the National Bamboo Mission. However, it is important to note that while bamboo origin ethanol may have a relatively low environmental impact compared to fossil fuels, it is a low value application of bamboo biomass and also has a higher environmental impact than various other bamboo derived products and applications. The major advantage of bamboo as a resource in the circular economy is in its inherent potential for reuse and recycling. In the absence of irreversible processing steps, it is possible and commercially viable to have multiple use cycles of a single bamboo resource. For example, a column of bamboo originally used as scaffolding may subsequently be turned into furniture or household items, then broken down into scrimber, and finally at the end of its life converted to ethanol or incinerated. These cycles would last 5-10 times longer than the time taken to grow that equivalent amount of bamboo biomass. For example, Musso International's 30-year warranty on its products means that they can grow the same amount of bamboo biomass 5 or 6 times over depending on species and climate in just one use cycle of one of their products. In conclusion, the advantages of bamboo are multifold, be it as a part of the natural ecosystem, as a carbon sink, soil quality enhancer, erosion protector, and food source, as an important crop in integrated farming systems and rural cottage industries, as a promising feedstock for bio-based applications with the fastest biomass growth rate, or as a valuable industrial raw material. Bamboo can be a valuable resource in transitioning away from a fossil-dependent economy. However, difficulties in breeding, limited geographical distribution and availability, labor-intensive harvesting, and existence of most economic applications in informal and small-scale sectors are some of the drawbacks that need to be overcome. There is a need for further research and investment into sustainable bamboo production as well as valorization pathways and economic applications. It would be apt to describe bamboo as a dormant colossus that is a potential leading bioresource of the future.